Hi, everybody. Welcome to week 10. I'll start off by apologizing that we got a late start this week, but there are a lot of moving parts to this learning module, and it took me longer than I anticipated to get them coordinated. This is going to be one of the more interesting and enjoyable modules, however. We have a good-sized assignment that I'll give you some extra time to work on, especially since we're starting late. And just to let you know, we have coming up in the next couple weeks 2 modules on digital preservation, just to make sure you have enough time to work on your final projects, and because we've got at least one more large assignment to do, I think I might compress those 2 weeks into 1 week, and we'll focus digital preservation on primarily web archiving, which is a really exciting field. But back to this week's learning module. As I mentioned in the introduction page for this week, librarians, archivists, and information managers of all types and kinds have had one primary tool that they use throughout history, and that is the information repository, library, information system that they use to control and access the information that they manage. Now, in early days, the repository was the information system. Back in the times of the ancients, Egyptians, Greeks, Romans. And there wasn't really, and as far as the evidence shows, there wasn't any index or catalog system that accompanied the repository. And the repository was known to the people who worked there. And it was manageable in that sense because the amount of information was not almost infinite the way it is in today's society. But as contemporary information managers, the primary tool that we will use is an electronic catalog or an electronic repository that is a server-based software application that we'll use to manage the information under our purview. So it's important for us to take a good look at how server-based software is produced, licensed, and the different categories of information management types of software that are available to us. And this is important. I mean, we've touched on this in the previous learning modules a little bit, but it's important for us to focus on it because as information managers, you'll be called upon at some point in your careers to recommend and evaluate an information management system that is multi-user designed and server-based that you'll use in whatever environment that you work in. So we'll talk about how the software industry has structured the licensing and release of server-based information management packages. We'll talk about categories of information systems that you'll encounter and how they work together. And then we're going to look specifically in detail at content management systems, which are a fairly recent development in the field of software design. And there are a variety of content management systems that you can use to actually build a really solid, good quality information management tools from that require little or no programming. And our weekly assignment, the part that makes it really interesting this week, is that I've built a content management system server for the class that we'll actually work on. And you'll get to use some of the administrative features and build some information structures online as part of your assignment. So I think you'll have fun. Sorry we started late, but it'll be a good week for us. Now, how software is produced and licensed is an important consideration for when you test and evaluate software that you might want to use in your work environment. We're starting to see a shift in the software industry, whereas everything used to be commercially produced. And up till the late 1970s or early 80s, most software that was produced was hardware dependent, meaning that the hardware was designed and constructed first, and then the software was architected to run on a specific piece of hardware. IBM is famous for this type of business model where they produced big computer systems, big hardware, room full of hardware components, and then the software is a necessary part, but it's almost like an afterthought in some ways to using the hardware. The personal computer revolution saw a big shift in that kind of model to where software became hardware independent. You could buy a piece of software off a shelf to run in your personal PC that could be run on a number of different types of hardware platforms and operating systems. Today, server-based software functions a lot more like personal computing software than it does mainframe type software that was used in the 60s and 70s. You can download server software and run it on a variety of different machines, variety of different operating systems, and it doesn't necessarily matter within a certain extent. I mean, there's always hardware requirements, but the hardware requirements are becoming less and less important to being able to run a server than they ever used to be. Now, commercial software is produced to make a profit, and so there are a number of different licensing models. It's something that is important to note is that with commercial software, you don't ever buy the software outright unless you just, the only way you own software outright is if you hire a programmer, develop the software yourself. Software is copyrightable and patentable, and so when you buy commercial software, especially server software, you're going to encounter one of three licensing models. Now, the least used licensing model for commercial server applications that are designed for multiple users is called the per unit or per copy of software model, where you just pay one price and you get one copy of the software, and it doesn't matter how many people you have connect to it. You're able to have as many users as you need. There are some applications out there offered at this kind of price model, but it's not that often seen. The two most used are called the per user or per connection types of license models. Now, a per user license model or a seat-based license model is where you have to tell the software vendor how many user accounts you're going to have on the system, and then they issue you a license key that'll allow you to have like 10 user licenses. A per connection model differs. Per connection model or a concurrent user model allows you to have as many user accounts as you want, but it only allows you to have a certain number of active users connected to the system at one time. So you'll instead tell the vendor that I want 5 concurrent connections, 10 concurrent connections. That's sort of a small to medium size operational limit, 5 to 10. And that's usually the ground floor that they'll offer, so like a 5 to 10 concurrent user license. Now, along with the initial license fee that you'll pay for one of these three models for commercial server software, you'll also be charged a annual support fee, and that generally the industry informal standard is that the support fee runs at about 18% of the original license fee that you pay. Now, the license fee that you pay up front depends on, for example, how many users or how many connections you want, and then you take 18% of that, and that becomes your annual fee so that you can have continued support and upgrades for the software. And at Microsoft, Microsoft would never pay for more than 18%, and we used to have to really negotiate hard with our software vendors to get them down to that, because the corporation just wouldn't ever budge on that. So you'll see some vendors try to charge more, but 18% is really an industry type standard. Now, there are definite benefits and drawbacks to the commercial software model. You buy a commercial application. In the library world, there's 5 or 6 different electronic catalog vendors, the major catalog vendors. And the reason that libraries use those is that, for ensuring that the software is bug-free and that users can access it whenever you need it and you have very little downtime, you need a high degree of quality control and testing. You also need to be ensured that you're not going to need to have drivers or special software components written for your major purchase, that allow hardware compatibility. And with large multi-user systems, you're going to need regular updates. There's going to be bugs identified, and you'll always want new features. And so the commercial software model allows you to get on board with those. That's usually part of your annual support fee, that you get your bug fixes, you get a regular, at least once a year update. And if you're lucky, then you can, when the company is ready to start work on next year's version of the software, you'll be able to put in a request for a feature that you want to have added to the software. Normally with commercial products, you get 24/7, 24 hours a day, 7 days a week support, unless you're dealing with a really small company, which you might get less. They are generally going to provide you with training services and documentation. At least some training and documentation will be part of the initial purchase price. And there is a certain amount of indemnification that you get with software, commercial software purchase, in that if you're running some service, information service where you are charging and you need to for example, collect sensitive user information, credit card ID numbers, and so forth. If you write that software yourself, then if something goes wrong with the software, you're on the line if somebody sues you because your system got hacked and their identity got stolen. With a commercial software purchase, you can usually push the risk of getting sued off to the vendor, at least at the point where you can share blame if something does go wrong. And turns out to be a flaw with the software. Now, there are always drawbacks to any type of software purchase. And with commercial systems, you have that annual support fee that you have to pay in order to get your upgrades and your bug fixes and so forth. So there's an ongoing investment for your organization. The scope of support services after the first year or two might also be more limited, and you may need to purchase a premium plan, or you may have to pay on like a per call basis for support. So depending on the type of application that you buy, you may have additional costs there. And then, of course, when you're dealing with a commercial vendor, they're trying to make money, so they want to keep the customization down. So they will be happy to do customization for you if you pay them a lot of money, and this is called professional services. And when you have a software vendor come in and demonstrate their product for you, they'll always tell you that, well, this is our off-the-shelf, our basic package, and our professional services team will be happy to talk to you about customizing the system for any of your individual needs. Well, you can bet that you'll pay a lot of money for that customization service. So money is the big drawback with commercial software. You're going to have money and continue to have money as long as you use a commercial application. Now, a growing alternative to commercial software packages is called open source. The term open source comes from the idea that the source code, the actual intellectual property behind a software application, is open and available for inspection and modification. So with open source, you not only get the application free, but you get the source code free, which means that you can do the customization yourself, and all it will cost you, at least in theory, is to pay a developer to make customizations for you. Now, this is an informal movement that developed in the early 1980s. You also hear the terms which aren't used as much anymore, freeware, shareware, openware, etc., which were sort of precursors to the major open source movement. You may hear and see around the internet that information should be free, and that's kind of the philosophy behind open source software. And there's sort of an economic philosophy or an economic premise behind the open software movement, is that with commercial software, you're paying for a product, and the product includes a profit margin for the company. So with commercial software, you're divorced from the actual programmers who develop the software, and you're really giving money to a company. An open source economic premise is that IT expenses should be focused on paying people to produce software and not using the software itself as a commodity. Now, of course, through its history, the open source movement has been vigorously criticized by large software companies who have an economic stake in proprietary software. And the software producers like IBM and Oracle and Microsoft and so forth, are joined by all of the companies that are software resellers, and those are called value-added resellers, or VARs, in the computer industry. Well, they don't like the fact that you can get software for free that competes directly with their proprietary software. And so a great deal of the animosity towards Microsoft, for example, was that Bill Gates wrote an open letter into the computer user community in the early 1980s saying that, you guys need to respect our proprietary software licensing model and not make copies of Microsoft Windows or MS-DOS and just distribute them to your friends. And since then, there's been kind of this chasm between the open source and the commercial movement. Now, the commercial companies have seen that open source is a huge success, and so they are trying to make inroads. So every major company now that produces commercial software also has little freebie open source and free access products that they offer. Microsoft has a variety of different free tools and add-ons for Windows that either come packaged with Windows, like Windows Media Player or Internet Explorer, that come part of the operating system. IBM has Lotus Office that they offer on an open source basis, and Oracle, until it sold off OpenOffice, certainly had the OpenOffice platform that they were maintaining. So in general, there's a movement toward open source software. And this is a very good thing, but it has its benefits and some major drawbacks as well. Open source software is usually available on a community basis, meaning that a software application like Drupal or Joomla or Map Server, which is a free open source geographic information system product, those are generally maintained by a community of volunteers. And there's very few people who are actually paid to maintain that software. And a lot of the financial support comes from donations, which can be very uncertain. You can go to an open source product's website like Drupal.org or mapserver.org, or you can go to open source repositories to find open source software. A lot of them are based on the GitHub repository model. So if you've heard of SourceForge, that's another repository. GitHub is both a repository and an open source software product, so it's a little more confusing. Your support is usually on a community basis as well, so you don't have a number that you can call if you've got a software problem. You've got to post a question to a forum and hope that a volunteer wants to answer your question. And a lot of times the volunteer support on these sites is terrible. So it's a major consideration. I just have to, we have to be honest about it. I love open source software, but if I've got a problem with it, it's usually a real bear to try to get it fixed. Open source software movement has kind of moved alongside of the open access and copyright-free licensing movements. So you'll see the new General Public License, or GPL, license as being the term that a lot of open source software is offered under. GNU was is a movement to provide a Unix-like operating system for free. It spurred a lot of different ideas for Linux and Red Hat and so forth. And GNU is actually one of those geeky recursive acronyms that means GNU is not Unix, GNU. And the GPL stands for General Public License. And that basically says you can use this, you can modify it, but I get the credit because I wrote it. You'll also see copyleft, which is a term for, instead of copyright, which is seen as a conservative type of movement where you're asserting your rights not to share the software. Copyleft allows you to share the software. Now, the benefits to open source software are obvious. It's free to own, meaning that there's no upfront license or support fee. If you have the technical wherewithal, or you know a programmer or can hire one, it's free to customize the software, usually within the limits of the license that it's offered under. And there is usually some documentation and community support that goes along with the software that's free. Now, the drawbacks to open source software are many. So before you use an open source product, you need to be well aware of these and kind of open-eyed about it. But While most large open source projects like Drupal and Joomla, etc., try to make a very high quality product and test it and control the quality of the coding, you can't ever really be sure what goes on, because volunteers are writing code for these open source products, and there's no telling really, unless you go and visit them and look at their operations, to tell exactly how well they do quality control and testing. Because volunteers are working on the projects, updates and bug fixes can take a long time before you get a new version. Again, the larger open source products are maintained pretty regularly, but it's always a risk. Sometimes the documentation is not that good, or it's very limited. If you decide to commit to an open source product and you find that it's got a major bug, or it's not compatible with one of your hardware or one of the other systems that you use, having a bug fix or a feature improvement to that system will cost you money. You'll have to hire a programmer who knows that open source product, who can write the improvement or the fix for you. My major problem with open source software is the support is terrible. You often get people who are volunteers, they're all volunteers in the support service for open source software, but you often get volunteers who are new, aren't really interested in your problem. They might be interested in somebody else's, so they might not give you a great answer. It can take them forever. If you ask a question, you have to post a question into a forum, support forum, and hope that somebody is going to be trolling around for new requests and pick up on yours to help you out. Only with the larger projects, open source projects, like the Public Knowledge Project produces publishing software, and that's actually an open source consortium of universities who produce that, and they can actually put some money into support, and you get some good support, a better, at least, support service with that kind of software. The other drawback to open source is that the lifespan of the software is uncertain. You don't know how long this project is going to last before all of the volunteers decide to go to a newer, more nifty, more interesting project. So there's a good risk of a short lifespan and early obsolescence. And of course, with open source software, there is no indemnification. If something goes wrong with the software, causes a major user problem, causes somebody some sort of damages or loss who uses your service through the open source software, and basically you're stuck with all of the liability for that. You can't sue the open source group. That's one of the licensing considerations that you need to be aware of. Now, the third option is to build your own software. BYO, in other words. Custom software is something that you hire a developer to write from scratch for a specific purpose. Custom software may incorporate other pre-written components like a database or a web server. It's very expensive, though, and unless you've got a grant or you've got institutional support, it's going to cost a lot of money, and it's going to not only cost money up front, but it'll cost money for you to support the software over the long term, because software has to be updated regularly, bugs need to be fixed, features need to be added, problems need to be solved. So it's a long-term commitment to both staff and money. Mainly large institutions do this. So a bank may write its own checking account software, like Wells Fargo Bank of America or something, rather than opting to have another, to use a commercial product. But they're going to pour a lot of money into that. They're expecting to get money from fees and interest and so forth out of their customers to pay for it. So custom software, it often sounds like a good idea to write your own application when there's nothing else available, but you need to really make sure that nothing else is available when you go for the custom software option. And really nowadays, there are so many software products out there, or at least products that you could make work together, components that you can make work together to solve most of your information management needs, that there's less and less need for custom software to be built. Usually it's just customizing existing software today that needs to be done rather than writing a lot of new applications from scratch. Normally you only want to write an application from scratch when a lot of organizations are going to invest in it and use it, either as a product or as like a consortium. Content management systems are a really good example of why there's less need, especially in the information management field, why there's a less need for custom-built software. Because content management systems provide a lot of tools and components that you can sort of put together to make work for you. So let's talk about different categories of server-based software. Well, let's start with general software and we'll move up to server-based here. So the lowest level of software, the software that talks to hardware directly, is either firmware. And firmware is basically the lowest level type of coding, and the program code is actually embedded in the hardware. And firmware allows the hardware to operate. So there's firmware in your central processing unit, for example. Drivers are the next lowest level of software, and drivers talk between your operating system and the hardware and the firmware to tell the operating system how to access and use a particular device. So you have drivers for everything on your personal computer, for example, for your mouse, for a microphone, for your display monitor. And usually those drivers are packaged together, and nowadays you don't have to install them separately very often. Either they're packaged on your computer operating system, like Microsoft goes to great pains to make sure that there's libraries of thousands of different types of drivers in Microsoft Windows so that you can just install Windows and the operating system will recognize all of your devices. It's a little different with open source operating systems like Ubuntu and Linux and so forth. You do have to manually install a lot more drivers in those cases, although they get better as time goes on. Your operating system is next. That's the basic platform upon which all of your application software runs, and servers and personal computers both have operating systems. Server operating systems are designed for multi-user access, whereas a desktop operating system is designed for essentially one person to use the system. You have your desktop applications like Microsoft Office, and those are either open source like OpenOffice or they're commercial. Then we have web applications. These are mostly server-based, and we have traditional server applications. Now, there's a lot of different nuances and subcategories and so forth, but that's basically the lowest to the highest level. Now we could go up into the realm of other specialized types of applications for specialty computing systems. For example, a genetic decoding computer system has its own operating system and its own built-in application that functions in a very specialized way for very high transaction, high computing operation type of computing. But what's on the list here is the basic lowest to highest level. Now, in the category of server-based software, we have a number of different types of servers. Now, server is a kind of a broadly used term. We can use the word server to refer to a piece of hardware that you buy to run an application on. That can be a server. A server can also be a specific piece of software that runs on server hardware. And one piece of server hardware can run multiple pieces of server software. And nowadays we have virtualized servers, which means you get a number of different server components that are sort of tied together with a piece of software that makes it, instead of just look like one server, you might be able to have 10 individual server instances running at the same time. And then you can run different applications on each one of those 10 virtual servers. That's a little beyond our pay grade for this course, but we will talk, when we go to digital preservation, I will have a section in the textbook that you bought to talk about virtualization and data center applications like that. So the lowest level, the most basic kind of server is called a file server. And basically it provides multi-user access to files that are on a shared disk on a server. We're all familiar with the notion of a database management system or a database server. Almost all information management applications include a database server of some sort. Media servers allow access to audio and video, digital audio and video. Those are also called streaming servers because they publish and distribute the media in a format where you get each frame of the audio or video that it gets sent to you in a stream, a data stream, as opposed to just downloading a file to your desktop and playing it back there. Web servers, of course, little explanation is needed there. Mail servers or communication servers of different types. We have mobile servers, we have email servers, we have different servers that are designed to promote communications of different types. Then we have a whole class of servers that are security oriented. These can be proxy servers where a server actually takes and verifies your identity and then passes you to another server, and that provides a barrier or a firewall that keeps somebody from being able to directly connect to your application server and hack into it. So you put a proxy server out in front. An authentication server, whenever you log into your network at work or at school, your identity is stored on an authentication server that verifies that you are eligible to access resources on the network. And then there's a variety of security monitoring servers, which we don't really have the bandwidth to talk about. Then the biggest class of server software is application servers, and these come in all different shapes and sizes, but basically whatever you want done on a server is an application that runs. Now, an application may be a combination, for example, of a web server and a database server, and maybe some other types of server components that work together to provide application access. So like when you log into your bank account for whatever bank you use, the online application there includes web components, it includes compiled program components, which you don't see, that run behind the scenes. It includes mail services, and it may include media services, but it certainly includes a variety of database services. There's different classes of application servers. There's GIS servers. There are record-keeping servers, etc. Content management systems are one subclass of application servers. And originally, content management systems were developed to control the publishing of web content so that large organizations could make sure that always the most current type of content was available on their large website, their corporate website. And there are a number of different companies that still produce content management servers for the web. In fact, here at UNM we use one called Hannon Hill, which is an okay application. It's got its major drawbacks, but it essentially coordinates access to editing web pages and controls the style of the web pages and allows you to expire content when it's outdated, and to help enforce some sort of integrity to the organization's website, in this case UNM. Another class of content management system is one that allows you to create and publish whatever content you want in a very flexible framework. And that's what we're going to talk about today. So I just want to give you kind of a diagram here of kind of what a side view of a server, it kind of looks like a tectonic or geological layers. But there's different levels of software applications that go into running a server. We've gone through all of them in sort of brief overview, but what I wanted to show you was that all of these different layers work together. We have the hardware at the bottom. We have your drivers and your operating system that talk to the hardware. On top of that, most application servers use both a database and these days a web server. And the application server itself is what the users interact with, and that's what they see on their end. In addition to the application server, database, and web servers, depending on the type of application, so going back to the idea of a bank software or Amazon.com, an e-commerce software, there might be some sort of what's called middleware or coordinating software that works between the database, the web, and the application front end to make sure that user requests aren't lost and they're shipped off to the right locations in the system, and that they are saved properly, and that a variety of different maybe workflow tasks occur as a result of you, for example, on Amazon, purchasing video or downloading a Kindle e-text. We're not really going to deal with the transaction or the middleware software. That's more technically oriented. But we are going to concentrate further on the application software here. Now, an application server and all of its parts and pieces, like we saw in the last slide diagram, needs to be housed somewhere, needs to be hosted, in other words. Now in small offices, small operations, hosting is done on a computer that's in the office. It might be a server class piece of hardware or it might not, depending on whether you've just got 2 or 3 people who need to access it or if you've got maybe 10 to 15 people. That's usually called back office hosting, meaning that the server is usually in the back office. It's in a closet somewhere in the back. You move into larger hosting scenarios where you, for example, here at the library or at the bursar's office or at enrollment services here on campus, you need more robust hosting services. You can't just have a server that's running on under somebody's desk or in a closet somewhere. So you need a data center, and the data center provides power conditioning, provides air conditioning to keep the hardware cool. It provides consistent network access, and it provides security monitoring services. And for medium to large operations, like here at UNM, those examples I just mentioned, it's a much better option than a lot of individual departments trying to run their own servers. The downside is that there's usually extra costs and there's always bureaucracy. So, I can't just, in my work here at the university libraries, I can't just put a server up anytime that I want. I have to make a request. We have to go create a plan. We have to schedule the plan and the implementation. We have to go through development phase and integration and testing phase, and then finally release it to production. So there's quite a bureaucracy involved when you get into the sort of larger scale hosting scenarios. However, you lose a lot of the risk that you have when you're just hosting a server under your desk, in that you've got somebody else who's worried about network connectivity and safety, security, and backups and so forth. Now, a third option, which is very popular right now, you often hear the term software as a service or cloud services, basically where you push off the responsibility for running your application onto somebody else. And they let you have access to your application that runs on their hardware and their software framework and so forth. Now, there are a lot of vendors out there who provide software as a service, cloud services, hosting services. And if you just Google hosting services, you'll get a whole bunch of results for people who want to take your money in order to host your server or application. Now, the upside to that is it's usually very inexpensive. It's easy to get started and easy to run. You don't have to have a lot of hardware investment or IT investment on your end. However, the caveat emptor, or the buyer beware clause, is that many different hosting services, they're not all created equally. And many hosting services provide bad backups. Some of them provide no backup at all unless you pay extra for it. A lot of times they don't update regularly the versions of the software that they host. They frequently, I've had this experience myself with hosting services, when they upgrade, they might do something wrong. If they upgrade their hardware or their software, they might do something wrong that wipes out your own data unless you have it backed up. So you need to pick out a reputable vendor if you're going to go that route, the sort of the cloud route. And just be aware that there's a good chance that your data or your application can get lost, so you need to make doubly sure that it's being backed up either by the vendor or you or both. So now let's move to talk about Drupal. Drupal is an open source content management system. You've probably heard of it. It's extremely popular right now, and it's used by a lot of large organizations. It has very good support. It's very flexible. There's lots of options for it. It's easy to learn and use, and we're going to use it in this class. So, it was written originally by Dries Bydart, who is a student at the University of Antwerp, and in 2000 he wrote his own student application called drop.org that he hosted out of his dorm room initially. And it was an organization that let students post assignments and schedules and so forth, services that apparently University of Antwerp didn't provide at that time. Once he graduated, he and there was another major developer for Drupal, decided to turn Drupal into an open source product. So in 2001, they created the first stable open source public release of Drupal. Drupal itself is like a phonetic equivalent for the Dutch word for drop. So originally it was called drop.org. It was changed to Drupal. And that second P got eliminated somewhere along the way. Now there's a large Drupal community, and it is community maintained with volunteer programmers and volunteer contributors. We'll get to the contributors part in just a second. Right now, the current release of Drupal is the 7.0 series, which is a major improvement. Which is something very good about Drupal, is each major upgrade, version of the software has been extremely, has matured the software a great deal. It's been and added a lot of extremely useful features. There is a software website, Drupal.org. You can go to download the software, any of the components that go with the software, like modules we'll talk about, and to get support, background, check the status of community projects, etc. Drupal is very widely supported by cloud service hosting providers. And this URL here at the bottom of the page will direct you to a good review of major hosting providers. One of them that's fairly good, I didn't use it for our server, which is probably one of the reasons why I took an extra couple days getting it running, but is monster.com. I believe that's on the list that's on this URL here, if you're looking for a good hosting provider. A lot of large organizations use Drupal. The most famous, of course, is the Obama administration White House website. Whitehouse.gov is a Drupal website. And the Louvre Museum also uses it. A number of U.S. government organizations and agencies. And it's used for a variety of popular software support all over the web. If you go to Drupal.org, you can get a list of major websites that use Drupal. I put this little diagram up here to show you how Drupal is structured compared to our generic diagram in the previous slide. But of course we have our hardware, and we may have like a virtual server layer, which we're not going to talk about in this class because it gets a little too far afield for us. But Drupal runs on a Linux or Windows operating system, and I've run it on both. It works great. It also needs a web server, and it runs on Apache or Microsoft's Internet Information Server just fine. You can also run it on a couple of other different web server platforms, but I haven't done that myself. And you can run it in secure or non-secure mode on the web server, which is good. Drupal also needs a database, and most popularly, you use the open source, freely available MySQL or PostgreSQL database servers to run Drupal. I understand it'll also run on Microsoft SQL Server. I think I might have done that once years ago. It took some extra configuring and so forth. Drupal is written in a very popular web programming language called PHP, which actually the programming language is called the Hypertext Preprocessor, and through some shenanigans, the abbreviation for the language got changed around. Instead of HPP, it's PHP. PHP is easy to learn as a programming language. It's used all over the web, and Drupal is written almost exclusively in PHP. That is one of the beauties of the software package, is that because PHP is so easy to learn and use, you can make modifications to Drupal fairly easily. And Drupal is even structured to allow you to make major additions to the software without having to crack the actual core software code. So once you have the database, the web server, your PHP installed on your operating system, you need to install the Drupal core application server, which you download from Drupal.org. And as I mentioned, Drupal allows you to make major additions to the software and add major features without having to bother the core application server. Drupal calls these modules. There are literally thousands of modules available on Drupal.org that have been written by community volunteers for different purposes. Now, the module may provide any sort of functionality. So it might allow you to embed maps on your website. There's many GIS modules. There's many text formatting and publication modules that allow you to add file attachments and format text and so forth online. There's many other special feature application modules. Basically anything that you would want to do online. There's Facebook integration modules, Twitter modules, social media modules of different kinds. Anything you would want to do online, you can find a module on the Drupal.org site. That's kind of the beauty of it, is it's because of all this community involvement in developing software modules. Drupal is a very extensive framework for a lot of different content management kinds of functions. Now, this is a list of the sort of core features that come with the basic Drupal installation. And I haven't added but a couple of different modules to our class Drupal server, just because I want to concentrate on sort of the basics. And I'll let you all look around for modules that you might like to add to the server, and we'll negotiate whether we have time to do that in the class here. But there's a basic menu structure that you can customize in Drupal that allows you to create any kind of navigation framework across your website. Drupal page layout is structured, and that's a characteristic of content management systems, into blocks. And the blocks, you can organize your web page layout in by using these blocks, which I've got a diagram of here later on. You can apply a variety of different visual themes to Drupal so that even every user can actually have their own visual theme and layout for their user account on a Drupal site. I've just got the one, I think, enabled, the one visual theme that we'll use, just not so we don't confuse anybody who's learning the system. Drupal has a built-in controlled vocabulary tool, which is very nice, although it's not when we say taxonomy, the controlled vocabulary or taxonomy tool is really designed to handle hundreds of terms or tags for classifying content on a Drupal site. It's not really made for thousands or hundreds of thousands of terms like major taxonomy vocabularies have. So it's a lightweight taxonomy tool. Every user has their own account, and you can track user activity on each account. You all will get a chance to do that on your own accounts. Each user can make comments or can vote on content on a Drupal site, much like you can on Amazon or other types of e-commerce sites. Drupal has some nice reporting tools for system administrators. As we've talked about, Drupal allows you to add modules, and adding a module is very easy in Drupal. It's like a 3 to 5 step process depending on how complex the module is. Most modules you can just drop into Drupal and they start to work. Drupal is organized by a system of content types. So every piece of content that you add into a Drupal site has a type. And the default types that you have are articles, which are simply little story items that can be embedded into a page. You actually have web pages, which take up the entire web page that you can create. We have a special feature called a book in Drupal, which allows you to bind together several web pages or articles under one hierarchical grouping. So you essentially can send somebody to your book, and the book will have individual pages in it with different content, and you can manage each page as a separate record in the content management system. Every user gets their own blog by default in Drupal, so you can start your own blog right away. You don't have to set anything up after you've registered with your user account. Drupal also has discussion forums that can be moderated or they can be open, where you can divide discussions into individual topics or questions, and people can reply in sort of a threaded format where you see somebody posts to the forum, somebody replies to that, somebody replies again, etc. And then there's user polls, which you can vote, and you can create a poll very easily. And I've actually put a poll on our front page. Drupal has a very simple sort of organizational idea behind it. Every record, every piece of content that goes into a Drupal site is called a node. And a node you have to think about as like a leaf on a branch. The core Drupal server is the trunk of a tree, and you can organize branches to sort of keep content separated out, and each branch has these nodes. And a node has its own fields and its own attributes, and each node is associated with a content type. I just screwed up here. Let me get back to our... There we go. Sorry about that. So here we see the Drupal core server at the top. We have our content types, which control the fields and the display behavior of each type of node under it. And then we can optionally create these branches or paths to the content. Addressing a record in Drupal is very easy. You see this is the URL actually to our class website, and the URL for the website itself is here in black, infomanagement.org/info504. And then the Drupal address for each page or piece of content in the Drupal site is prefixed with the word node, a slash, and then the record ID of that node. And it doesn't matter if that node is an article posting, a book, a page, a user poll, or a forum posting. Each piece of content is a node that has a record ID, and so there's a very simple address system for Drupal nodes. As I mentioned, content management systems tend to control the layout of content. And that makes it easy to sort of standardize how content is displayed and where it's displayed. This is sort of the basic Drupal layout. There are actually several other zones or layout blocks that I didn't put in here just for space, but these are the major ones. Any content that comes up dynamically, like if you search for, enter a search term into a Drupal search box, the search results are going to come up here in the body. This is also where your pages are going to display so you can read them. The body page part of the page is dynamic, and most of these other pieces around here are pretty static that surround the body page. So there's a left sidebar where we put our menus and our login box and stuff, and you can also put them on the right sidebar over here. If you want the content to be able to expand over to the right quite a bit, you might want to just leave all of the navigation tools on the left and leave all of this so that the body part of the page extends all the way over to the right. There's headers and footers and little intermediate content zones where you can put something like a message, or you can say that this is a UNM sponsored website in one bottom area. You can put your copyright notice or your web accessibility link or your feedback link in another bottom area. Then we've got a footer down here at the bottom for final logo display and stuff like that. So all of these areas here just sort of structure where major pieces of or major features go. So usually use one of these preface areas has got the search box in it. Another might have a top level menu bar that goes across the top. Another one's got your logo and your site name in it, etc. So we just completed the part 1 of the online lecture. Go take a break for a few minutes and then come back, and I'll actually go through the Drupal demo with you and show you how to do this week's assignment. The assigned readings are mostly about Drupal and about content management systems, and they're pretty lightweight. There are a couple of technical readings that I've assigned you, and don't worry about not being able to understand some of the PHP code examples or the configuration examples in those, because the articles provide just good background information about what Drupal is and what it can do and so forth. And whatever you learn about Drupal is such a hallmark of the content management system niche of application software, that whatever you learn about Drupal, it's going to apply to other types of content management systems you may use, like WordPress or Joomla. There's, at my last count, there's probably 100 different variations of different types of major content management systems that are freely available. Some of them are made for commercial platforms, and some of them are purely open source. But they all share a lot of the same components and features that Drupal provides. And then I'm going to give you until November 4th, Sunday, November 4th, which is not this Sunday, but next Sunday, in order to complete the assignment, which is to set up your own content types in our Drupal class website, post some records, start your blog, and configure your user account. Those are the major features, of course, along with commenting on your classmates' work of this week's assignment. So as always, if you have questions, need help, shoot me an email, give me a call, and I'm happy to help you out. Enjoy the demo, and I feel certain you're going to have fun with the assignment this week. Bye.